We're now going to take a look at how lines are related on the coordinate plane on a graph and look for patterns where we get parallel and perpendicular lines. A review of parallel and perpendicular. Parallel means two lines that will never cross. They're parallel to each other. Perpendicular is they form a T on the graph. So they could be any which way, but they form right angles, right? They intersect to form right angles. We have a couple exercises here. We're going to start off with exercise 1. And what exercise 1 wants us to do is graph these two equations. So we should know how to do that. This is the slope, and this is the y-intercept. Remember that? Slope and y-intercept. That's how I'm going to do that. So if you start at -5, 1, 2, 3, 4, 5, and then the slope is 3 over 1. So we're going to go up 3, boom, 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 over 1. Oops. Up 3 over 1, boom, 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 over 1. Boom, 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 over 1. Boom, 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 over 1. You guys have done this before? Just graphing a line, okay, and then connect those. Yeah, good luck. I'm going to have to kind of... Yeah, I knew that wasn't going to happen. I knew this was going to be impossible to do on here. Oh my goodness. Yeah, it's just this thing I'm writing on to try and get it to be good. There we go. Okay. I think there's a line tool on this thing that I just don't know how to use. There we go. Good enough. Alright, and then it's a line so it goes on forever. I need arrows. Okay, this one here, we start at 2. I'm just going to switch colors here. We start at 2. 2 is the y-intercept, and then we go up 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And then we go boom, 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 1 the other way. Boom, 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 1 the other way. Boom, 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 boom. So up to the right is the same as down and to the left. You should know that. And then we connect these the best we can. Anyways, hopefully you got a straight edge. You connect those, and what can we tell? What is the relationship? Well, first of all, what is the slope of equation 1? 3. What is the slope of equation 2? 3. What is the relationship between the slopes of these lines? Slopes are equal. Slopes are equal. What is the relationship between the graphs of these two lines? The lines are parallel. Lines are parallel. Okay? So... and that should make sense because slope is the steepness of a line. So if one line has a slope of 3 and the other line has a slope of 3, they both have a slope of 3. They're both going the same way, so they'll never intersect. They are parallel. So that's what we should get out of this little exercise here. Based on this exercise, make a conjecture about the slopes of parallel lines in the coordinate planes. Parallel lines have equal slopes. Or you could say, if two lines have the same slope, then they are parallel. Parallel. Okay? Some examples of parallel lines would be, and you could tell, see here, this one, these two have the same slope. These two, they don't, but they do. 3 over 6 is 1 over 2, right? So you can tell they have the same slope. This one here, you'd have to get them, well, the 4x minus 5y, 4x minus 5y, even if you got it y equals, you're going to subtract 4x and divide by -5, so you're going to have -4 over -5 for both of them. They're both going to be 4/5. They're both going to have a 4/5 slope. And this one here, you got to do a little bit of work to see it, but this one here, so I'm going to say, I'm going to do this for you. So 5y equals -10x minus 8. You're going to divide by 5, right? Divide by 5. So it's going to be y equals -2x minus 8/5. That 8/5 doesn't matter. You get the negative 2x though, right? So over here, 2x plus y equals 15. I have to subtract 2x from both sides. You guys did this in Algebra 1, where you had to get the y by itself. Y equals negative 2x plus 15. See that? So I get negative 2x, negative 2x. They both have a slope of negative 2. So even though they may not get when it's given, you have to get it y equals, and when you get it y equals, you'll see that the slopes are equal and that the lines are parallel. So I'm just going to extend my page here to do example 1. And example 1, this is already good. This one here, you got to divide by negative 3. Divide by negative 3. So I get y equals 3 divided by negative 3 is negative 1x. Negative 1x and then minus 3. So see how I have a negative 1 here and a negative 1 here? So these lines are parallel. This one here, I got to do them separately. So I got to do 3x plus 5y equals 15. I need to subtract 3x. So 5y, I'm going to do it down here. Why am I screwed? I'm going to have 5y equals negative 3x plus 15. And then I need to divide by 5. So y equals negative 3/5 x plus 3. And then this one here, I'll do it down here. 3y plus 5x equals 15. 3y equals negative 5x plus 15, and then divide by 3. And you could see it doesn't work. This is negative 5/3. That's negative 3/5. Negative 3/5 is not the same as negative 5/3, so they are not parallel. And then this one here, 15 over 5 is 3. So this is y equals 3x minus 2. So see how you have 3x, 3x? They have the same slope, therefore they are parallel. I think that's pretty simple. Now we're going to move on to exercise 2, what's going to get us to see perpendicular lines on a graph. All right, so we have, I want to go to green. Equation 1, the slope is going to be a half. In equation 2, the slope is negative 2 over 1. So let's graph this one. We're going to negative 5, 1, 2, 3, 4, 5, and then I go up 1 over 2. Up 1 over 2, up 1 over 2, up 1 over 2. Down 1, 2 to the left, down 1, 2 to the left, down 1, 2 to the left. All right, and we got this line right here. Oh, this one's much better. Oh, see, I jinxed it. I jinxed it. All right, there's one line. And then the other one, we'll just do it in black. No, we'll do it in red. No, we'll do it in purple. 2 is my y-intercept. And we're going down 2, 1 to the right. 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 Boom, 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 boom. Up 2, 1 to the left. And look what happens with these two lines if you did it correctly. See how they intersect like that? Okay, so what is the relationship between the slopes? Now the slopes are not equal. They're one's flipped and the signs are changed. That's called negative reciprocal. They are negative reciprocals of each other. Okay, negative means opposite sign, and then reciprocal means flipped. I think you've heard that word before. What is the relationship between the graphs? The graphs are, lines are perpendicular. Perpendicular. All right. So let's do another one here and see if it works or that was just a coincidence. So this one here is a negative 5. Boom, do. And then up 2 over 3. Down 2 over 3. All right, there's that one right there. it's got a 2/3 slope. This one's -3/2. So we're going to check to make sure it works. And this one's -3. I'll change colors. We'll go blue. -3 is the y-intercept, and then I go down 3, 2 to the right. Down 3, 2 to the right. Down 3, 2 to the right. Up 3, 2 to the left. Up 3, 2 to the left. This should be easy for you guys. You should know how to graph lines by now. And we intersect, and they do look like they intersect at a right angle. And what's the relationship between the slopes? Again, negative reciprocals. What is the relationship with the graphs? Lines perpendicular. So what's a statement we can make? I think this exercise is showing us that we want to make a conjecture. If two lines have negative reciprocal slopes, again, negative reciprocal, reciprocal, yeah, slopes, then they are perpendicular. They are perpendicular. All right, that's what we learned from this exercise. So some examples of perpendicular lines. I don't want to go through these. You could do them the same way as you did, but look at 3, -1/3, 3/5, -5/3. These two you would have to require doing some work. I don't want to waste time on the video. I just want to bang out example 2 here. Determine whether the following are perpendicular or not. All right, so are these perpendicular? Well, the slope is -1, and this slope is 1. So this is over 1, and this is over 1. The reciprocal of 1 is 1. If you flip 1, you get 1. So they are reciprocals, and one's negative and one's positive. So that, yes, these are negative reciprocals. This one here, all right, so I'm just going to tidy up my pen here. I'm going to do 3x plus 5y equals 15. And then I'm going to do 3y minus 5x equals 15. So I'm going to, what's this, plus? This will be 5y equals -3x plus 15. And then I'm going to divide by 5. So I got -3/5 for my slope. This is going to 3y equals 5x plus 15. Divide by 3. And I got 5/3. So look at -3/5 and 5/3. Yes, they are negative reciprocals. -3/5 and 5/3. The slopes come out to be negative reciprocals. Therefore, these lines are perpendicular. This one here is y equals -3x plus 5. And this is 15 over 5, which is just 3x. Okay, so now these, we have the negative, but we don't have a reciprocal. -3 and 3 are not reciprocals. It would have to be -3 and then 1/3. Those would be perpendicular. So these are not perpendicular. All right? And that's where I'm going to leave you, and we are going to do example 3 and the point slope form in class tomorrow, because I want to be real clear and make sure we're understanding this very well. So we're going to start class with example 3. I'll see you then.